Welcome to this presentation on C++ Future and Promise. In this session, we will explore modern asynchronous programming techniques in C++. Let's begin by understanding asynchronous programming. Asynchronous programming is an execution model where operations run independently of the main program flow. This allows a program to continue its execution while waiting for certain operations to complete, such as reading data from a file or receiving a network response. This approach significantly improves responsiveness and resource utilization. Now let's explore the reasons to use asynchronous programming in C++. It efficiently handles input-output bound operations, such as network requests or file access. It enables the utilization of multi-core processors with CPU-bound tasks, allowing for parallel execution and improving performance. It helps maintain a responsive user interface while performing heavy computations in the background. Finally, it simplifies complex concurrent operations by providing a structured way to manage asynchronous tasks. Now let's dive into the core concepts of C++ Future and Promise. First, standard future represents the result of an asynchronous operation that will be available at some point in the future. It acts as a receiver for a value that hasn't been computed yet. Here's an example. AutoFuture equals standard async, which takes a lambda function that computes a value and returns it. Later, when we need the result, we can get it by calling future.get, which will return an integer result. Next, standard promise is the counterpart to future. It acts as a provider that can set a value, which will be available through its associated future. Let's explore how to use standard promise and standard future together. Consider the basic promise future pattern shown here. We have a producer function that takes a standard promise of type integer as an argument. Inside this function, we simulate some work and set the value of the promise to 42 using the setValue method. We also have a consumer function that takes a standard future of type integer as an argument. This function waits for the result using the get method, and then prints the result to the console. Now let's explore the key methods available for futures. First, future.get waits until the result becomes available and returns it. It blocks the calling thread until the result is ready. Here's an example: standard future of type integer future.get. The integer result variable will store the return value. Next, future.wait waits until the result is ready, but it doesn't retrieve the value. This can be useful for synchronization purposes. For example, standard future of type integer future.wait. Now it is safe to call get. Third, future.wait waits for a specified duration. It returns a status indicating if the result is ready within the given time frame. AutoStatus equals future.wait for, and we are passing standard chronoseconds of 2, which means we are waiting for 2 seconds. Finally, future.valid checks if the future refers to a shared state that contains a deferred function result or exception. If future.valid, then we know it is safe to call get. Now let's explore the key methods available for promises. First, promise.setValue sets the result value in the shared state. This value will be available through the associated future. For example, standard promise of type integer promise.setValue 42. Next, promise.setException sets an exception in the shared state instead of a value. The exception will be thrown when future.get is called. In a try-catch block, we call promise.setException and pass standard current exception. Third, promise.getFuture returns a future object associated with the promise's shared state. It can only be called once per promise. For example, standard promise of type integer promise standard future of type integer future equals promise.getFuture. Finally, promise.setValue at thread exit sets a value that will be available only after the thread exits. This is useful for cleanup operations. For example, promise.setValue at thread exit 42. Now let's explore standard async, which simplifies asynchronous tasks. Standard async provides a high-level interface for launching asynchronous tasks and automatically returns a future. Here we have launch policy options. Auto future 1 equals standard async, standard launch async. We pass a lambda function and we compute and return the value. Next we have deferred execution, also known as lazy evaluation. Auto future 2 equals standard async, standard launch deferred. We pass a lambda function and we compute and return the value. Finally, the implementation decides whether to execute asynchronously or deferredly. Auto future 3 equals standard async. We pass the lambda function and we compute and return the value. Now let's look at a practical example of parallel computation. We can use standard async to perform multiple calculations concurrently. In the main function, we launch 2 calculations in parallel. Auto future 1 equals standard async calculate part 1. Auto future 2 equals standard async calculate part 2. When we want to get the results, we call integer result 1 equals future 1.get. Integer result 2 equals future 2.get. Finally, we return the sum of result 1 and result 2. Now let's explore the best practices and pitfalls to avoid when working with futures and promises. Always check the future status. Use wait for or valid to check if a future is ready before calling get in time-sensitive code. Handle exceptions. Remember that get will rethrow any exceptions that occurred during the asynchronous operation. Avoid calling get multiple times. Get can only be called once per future. Subsequent calls result in undefined behavior. Beware of lifetime issues. Ensure promises and futures live long enough to complete their operations. In summary, standard future and standard promise provide a powerful mechanism for asynchronous programming. Standard async simplifies launching tasks and getting results. Futures allow waiting for and retrieving results from background operations. Promises act as providers that set values to be consumed by futures. Here are some resources for further learning. C++ reference at crefrence.com/w/cpp/thread. C++ Concurrency in Action by Anthony Williams. Effective Modern C++ by Scott Myers. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.